Okay, so we're looking now at these spanning trees and trying to find the minimum spanning tree. So an example of this would be, like it says here, we've got electricity to 8 sites in the caravan park. So it's a weighted graph. We've got these distances given to us for each edge. So what we're trying to do is find the smallest amount of cable that we could use to connect all of these 8 sites. So how do we start? So what we do is we simply select a vertex to start with. It can be any vertex within the graph. So we start with P here. So P is our starting point. So then we look at all of the edges connected to P, and we find the one with the smallest value, because of course that's going to take the smallest amount of cable to connect it. So out of all of the edges connected to P, 10 connecting it to S site 2 will be the smallest edge to work with, so the shortest length. So then we've got, scroll down a bit, so then we start drawing up our minimum spanning tree. So we've got P, and we're connecting that to site 2 with a length of 10. So then we move to S2 and we start looking at which is the shortest edge that connects to S2. So S2 to S1 is the shortest with a length of 7. So we make that connection 7 to S1 from S2. Then we simply move on and we keep looking at the minimum distance. Now we're not just looking at the edges coming off of site 1, we're looking again at the edges coming off of site 1 and site 2 and this vertex P here. So we've covered this edge and we've covered this edge. Now if we look from S1, we've got an edge of 13 or an edge of 18. Otherwise off S2 we've got this edge of 8, which is smaller. It's the smallest listed, so we're going to go with that one. Just going to zoom out so that we can get a better diagram happening here. So that will connect us to site 3 with a length of 8. And we continue that process. So we've either got this 18 or we've got 9 or 13. So of course it's going to be that or the 11 coming off here. Now remember that we can't go back into P because that will create a loop, which will then mean that we haven't in fact got a spanning tree. So from S3 I want to go to S4 because that has a length of 9. Okay, so then we've got the options to either go 19, 18, or from P we could go 11. So 11 is the shortest length, so we're going to choose 11, which will take us to site 6. So these are the sites we've visited so far, we've got connection to. So from site 6 we can go 10, 9, we could go, so we've got our 19, 9, 10 or 18. 9 is the shortest, so we're going to go from site 6 to site 5 and a length of 9. And then we've got either this length 19, length 10, so or this 18. So it's the 10, so we're going to go out to site 7 with a length of 10. And then we've got the choice of 19 or 8. So again 8 or this 18, sorry, and 8 is the smallest, so going to choose 8, which will take us to site 8. And that will have covered all of the sites. And that will give us our minimum spanning tree. Now what we do is we work through the edges that we've covered. We simply add those up. So we've got edge of 7 plus an edge of 8 plus an edge of 9, which is these along there. Then we've got our edge of 10, edge of 11, edge of 8 up here connecting S8 to S7, another edge of 10 connecting S7 to S6, and last but not least S9, 9 which connects to S5, which gives us 72 meters of electrical cable that he needs. And that's simply the algorithm that we use. Simple as that. So I'll go ahead and do another example for you, looking at worked example 18 in the next video.